Good morning, everyone. On behalf of Ruby Collins and the City of Atlanta Department of Watershed Management, I'd like to thank you for taking the time to hear about the Peachtree Creek Trunk Stabilization Project in the City of Atlanta. My name is Chris Lynn. I'm the General Sales and Engineering Manager for Sekisui SPR Americas, based out of Atlanta, Georgia. To start off our presentation, let's talk a little bit about the city and Ruby Collins. Founded in 1847, the City of Atlanta and its Department of Watershed Management, which was formed in 2002, serve the water and wastewater needs of over 4.6 million people daily. In 1998 and 1999, under two federal consent decrees, the city has made great strides towards a sustainable water system through the separation of 11 miles of combined sewer in downtown Atlanta and repairing and rehabilitating over 373 miles of sewer lines, resulting in a significant citywide reduction of sewer overflows. The city currently maintains more than 2,150 miles of sanitary and combined sewers. Based in Smyrna, Georgia, Ruby Collins was incorporated in 1970 and has been serving municipalities throughout the Southeast as a premier heavy civil general contractor. They have completed projects with contract values up to $101 million and have completed projects with the City of Atlanta totaling over $400 million. Ruby Collins specializes in several construction fields, such as water and wastewater treatment facilities, sanitary sewer and storm water systems, pump stations, water systems and force mains, tunneling, and pipe rehabilitation. Getting into the actual Peachtree Creek Rehabilitation Project, as part of the rehabilitation efforts, the city was faced with the evaluation and repair of the Peachtree Creek trunk sewer. This 90-inch arched concrete sewer was cast in place in 1937 and totaled nearly 3 miles in length, with average daily volumes of 30 MGD and peak flows of 85 MGD. The area above the sections of the sewer that needed maintenance and repair included a thriving residential area, a city park, golf courses, suburban communities, and Interstate 75, making this project the perfect candidate for a trenchless solution. As you can see by the as-built from the original construction of the cast-in-place sewer, there are several joints in the concrete that are not reinforced and are subject to movement. The condition of the sewer was in very bad shape due to a 500-year flood event that exposed structural failures, including cracks, failures, and concrete degradation. All of this was impacting the local community environment. A combination of all these failures resulted in significant sewer spills that impacted the local community and environment. In these pictures, you can see the degradation of the concrete, which was soft enough to peel away by hand. The picture on the right was a non-destructive test for the strength of the concrete. Because it was in such bad shape, it did not yield a strength result. CCTV, sonar, and manned entry were used for condition assessment. It revealed and confirmed the non-reinforced joints, cracks along the crown of the pipe, and general degradation of the concrete that required immediate attention to this very important asset. Due to the location of the sewer and its surrounding areas, the cost to dig and replace the pipe, existing bends in the system, and existing flow levels in the pipe, the city and its consultants evaluated many trenchless technologies. To meet the demands of the project, spiral wound liners were chosen for the rehabilitation of the trunk sewer. SPR is a spiral wound technology for the rehabilitation of round and non-round pipe diameters between 36 to over 200 inches. This technology also offered additional benefits of being able to line sweeping 45-degree bends without interruptions and continuing operations in low velocity, live flow conditions. And you can see the profile that was used that included the optional steel reinforcement as part of the project. With this information, the City of Atlanta made plans for a solution, creating their invitation to bid in August of 2017 for the project, and Ruby Collins received a successful award and notice to proceed in May of 2018. Ruby Collins was commissioned by the city to repair the most pressing areas of the damaged sewer immediately after the flood and design a solution for the remaining 10,500 linear feet for the community so that future issues could be addressed. The scope of the project is detailed in this slide. It also included the training of the key Ruby Collins personnel at the Sekisui SPR manufacturing and training facilities in Japan and in Ruby Collins Yard in Georgia, where additional training and demonstration of the technology for 2 test pipes were conducted. Each of these sample pipes were lined and grouted by the Ruby Collins crews. One thing that I would point out with the picture on the right, we will talk about bypass as well as flow management considerations. One thing that was part of the lining process was to actually have 2 10-inch conduits to act as an internal bypass to bring flows down to lineable levels. As I mentioned, flow management was critical to ensure project success. This process started with the creation of a flow diversion plan at the R.M. Clayton Water Reclamation Plant. It was here where a downstream junction box containing several sewer lines came together just before the headworks at the sewer plant. This structure was utilized to dewater the sewer line to flows that would allow cleaning and lining to take place. In some cases, the junction box surcharged due to the capacity of the headworks, causing a backwater curve up the pipeline. To alleviate this from occurring, a slide gate in the junction box to prevent the water from backing into the sewer line being rehabilitated was installed. This is the upstream junction box that was used to divert a large portion of the flow to a parallel sewer line. A slide gate was installed that was able to be easily inserted while working the pipe and removed when not. There were times during a very rainy season when this gate had to be lifted for periods from a couple of days to weeks at a time. Due to the length of some of the line segments, Ruby Collins installed new manholes to minimize the distance for cleaning and lining. These new access manholes became permanent as part of the project. With the flow management measures in place, the next step in the project was for the pre-lining inspection and cleaning. Ruby Collins contracted with CES Deutsch to complete this work, where over 15,000 linear feet of the 90-inch pipe was cleaned and inspected, along with a 54 and 60-inch siphon. Upon completion, the Ruby Collins crews moved on to the lining portion of the project. Utilizing existing manholes and access points, the Ruby Collins crews were able to assemble the 82-inch PVC liner inside of the 90-inch pipe. The small crew used a continuous strip of SPR PVC fed from a spool above ground to the winding machine below to construct the fixed diameter liner. Each spool contains 500 meters of material, and once complete, a new spool was spliced to the end of the previous spool to form a fully structural, continuous pipe within a pipe. The SPR winding machine mechanically locks the steel reinforced PV strip together to form the liner. This process was continued and done between each line segment, with the longest segment totaling more than 1,500 linear feet between access points. Upon completion of the lining in each segment, the next step in the installation process was to grout the annular space. The liner designed for this project met the fully structural standard under ASTM F1741-18. Therefore, the project only required a cellular grout to act as a means of load transfer between the deteriorated hose pipe and the new liner. More than 5,404 cubic yards of grout were placed on this project. During grouting, a series of internal braces are installed to support the liner, while injection ports used throughout the line segment ensure that the annular space was completely grouted. As a direct result of their collective efforts, the City of Atlanta and Ruby Collins successfully completed the Peachtree Creek Trunk Stabilization Project, rehabilitating 10,500 linear feet of a 90-inch arch-tape sewer. The project was completed ahead of schedule and under budget, despite some weeks of interruption due to unusually rainy weather during the construction period. This project represents the longest and largest spiral wound installation in North America and one of the largest pipe rehab projects completed by Ruby Collins and the City of Atlanta. Trenchless technology offers many advantages to agencies when considering pipeline rehabilitation versus dig and replace. The advantages of Sekisui SPR's spiral wound products offered additional benefits that you see here to meet the demands of the Peachtree project and ultimately its successful completion. And they are lining the pipe bends. As mentioned before, there were several sweeping bends within the line segments that required no break or change in the lining technology. There were consecutive S-curves that proved to be extremely difficult, but were able to be handled by the SPR technology. We mentioned the ability of the product to line in live flow. This allowed the crew to work in varying levels of flow. As you can see by the picture on the right, the technicians were actually operating in flows up to their knees. And when the pipe had to be vacated during surcharge situations, the equipment could be left during these rain events when the pipe was completely submerged. Finally, as all of this occurred underground, there is minimal impact to the community. The citizens can continue their normal life. There were also many challenges for the city and Ruby Collins that had to be addressed during the project. Here you can see that access was a major issue for the city, but was satisfied by the spiral wound technology, keeping everything underground with a minimal footprint above ground. And then, as always, keeping the community informed about progress, potential impacts in their local area, and continuous updates were provided to the city and its citizens through a public information team that attended neighborhood planning meetings, board meetings, etc. To give you guys a better flavor for what the project looked like, here is a brief video of the actual installation with some of the highlights of the project to its completion. This concludes our presentation, and we'd like to thank you for your time. For further information regarding this project, feel free to contact us. I believe we also may have time for some questions.